So till yesterday, we have seen basic Python, and we have seen some kind of advanced concept called threading processes, multiprocesses. That's all done. So for today, let's look into writing files in Python. So let's say in operating system, we have files, right? Even these source code files also are files. So how do I write text files and binary files in Python is what we will look into today. And after that, we will go over the packages, how to use multiple packages within Python. So this multi-process, all this pip install, whatever we do, these are all packages, or in another term, it's called a library. So how to use those libraries, how to create our own libraries or packages, that we will look into today. So with these two concepts, we'll wrap up Python basics course, and then we'll continue with fast API for creating REST APIs. Then we will look into UI, how to build UI on top of these APIs. So let's start over. So far we have been uh, using Python shell to execute scripts. So from last class and the previous class, we have been using the files itself. So when I have one file here, I can execute that Python file with this command Python and the file name where we write the code. So let's create another file manipulation. Right. So in this, we are going to look at how to create files, update, add data to files. So as you can see, this folder doesn't have any text files. So these are all Python files. These are all text files in the sense it's all text files. But I'm going to create a new file from Python code and write some data to that file in this folder structure. So how do I create or open a file, new file, if I have to create from Python code? I need to use open function, and the name of the first argument that it accepts is the name of the function, the name of the file name. I'm going to give a.txt, and the second argument it accepts is the mode in which we have to open this file. Let's say if I'm reading the file, it means it will be opened in a read-only fashion. So if I need to write the file, then it will use write mode. So if I specify R here as a second argument, that actually means I'm opening the file a.txt for reading purpose. So that means if the file exists, it will open and starts reading the file. Meaning we haven't started reading the file yet, it will just open the file and keep it ready for us to read the data from it. So now there is no file called a.txt here. Let's see what this thing gives us. If I execute file manipulation, and we have this file not found there. No such file or directory a.txt. So there is no file called a.txt. That's why we are getting this error. So there is another mode we discussed just now, write mode. For writing, let's just open f equals open a.txt. And then this time I'm going to open it in write mode. So the advantage with write mode is it creates the file if it does not exist. If there is an existing file, if I open it in write mode, it will overwrite that file. Let's see how this works. And this did not throw any error, and a file called a.txt has been generated. You see, this is empty. We haven't written any data to it. That's why we are showing this as empty. So now I have opened the file in write mode. I can write the data, something I can write. Let's write with f dot write and I'll what do one more right all. This makes a sample text. Let's run and see if this gets stored in the data text. So the advantage here with W right now is that if the file doesn't exist, it will create. If it exists already, it will overwrite it. It doesn't add content to it. For adding content at the end, there is a mode called append that we will discuss in a bit. But for now, so we are opening the file and overwriting this file with this data. Let's run this. And let's go to a.txt and see if this got stored. This got stored. But sometimes that's OS handles files in a different way. So it's not always evident that it will write immediately. So when I open a file and write something to it, it doesn't always end up in the file immediately. So there is a buffer involved here. The operating system doesn't write data to the files directly every time we write through the code. It has some optimizations. So writing to a file is a costly operation. So that's why the operating system does some kind of buffering. So that once the buffer is filled, then only it will write to the disk. So that kind of situation is there. So whenever I have to make sure that the data that I write into the file ends up in the file, I have to actually close the file. So how do I do that? Is through f.close. This makes sure that as we have opened the file, and when we close the file, all the data that we are writing to the buffer is already flushed into the file. So this makes sure that all data is flushed into the disk or into the file. So this is a basic setup for writing files. So here we have seen a.txt having previously a.txt is there. Now I'll re-execute this code and I'll open a.txt. This has replaced the entire content of a.txt with hello, this is a simple text. So what if I want to add text to the end of the file rather than replacing the entire contents of the file? So for that, I have to use append mode of the file a.txt. Append mode is so f.write. This is another text. So this one I'm just going to off so that we can demonstrate. Now a.txt has this text. And now I'm opening the file in append mode. And this adds the data to the end of the file. So let's run this code. a.txt, and this is another file has been added at the end. So one thing we can observe here is that so this is one problem. We are seeing this entire contents in one single line. So there is a special character called \n, which is the new line character. We haven't written this character. Every time this code, when I'm typing one line and doing the enter or return key, so it's actually adding a \n character, new line. That is called a new line character. So I have to write new line characters also. Let's open this file. Let's add the new line characters also. So this thing opens the file in write mode, which actually is going to replace the entire captions. I'm going to write this at the end of that text. I'm going to introduce and new line character \n. This is going to add a new line character in the enter. The return key, if I press, that is what the operating system does, or any text editor does. So if I have this \n character, that is our new line character, it will add a new line. Let's execute. Let's go to a.txt. So now if you see here, this has introduced a new line. This, if it is in the second line, means this there is a new line character over here. Now let's do one thing. So in reality, let's see how this actually looks like. So let's open the same file. I'm commenting out this file. Let's open the same file and read that as text. Text goes read. Read does reading of entire text at once. So let's just print text here. And then f.close. So this printed along with the new line characters. Let's just print this not as a text. Let's do something like, how do I show the text is \n character is to scaling. Let's try text. It's not actually, when I'm trying to print it in the console or terminal, it's actually not showing the \n, but it's actually putting the new line character exactly. So in order to see this, I think I will need to use JSON. This I will explain in a bit. What is JSON? All this. So if I just serialize this text into JSON, to show the new line character. If you see the JSON text, it's actually giving \n in between. Hello, and this is text. This is what the system sees. When I'm trying to print this with print statement directly, it's going to replace this \n characters with actual new line characters. So this is the JSON representation of the text, and this is actually, we are trying to print this text. When I print this, \n gets replaced by the new line character. So this is how we read a file. And similar to reading, we also have seen append mode. So even in here, I can have, I'll just use \n character here also. Yeah, so if I run this, all lines will come in each of these lines comes in its own line. Okay, that's about reading, writing, appending. But there is a shorter syntax for this. If I have to do every time when I open a file, I have to actually close the file as well. So there is a shorter method for doing that. That is something called with keyword with open of a.txt in write mode or append mode as f. This is a new syntax. I can do file manipulation here. File.write. Yeah. Okay. Right. So now if I run it, if I'm using this kind of syntax, I don't have to use this f equals open, and then f dot close. This one I don't have to use. As long as I do this automatically, or when all the lines of code within this block are executed, it will automatically close this file. So that's something that we can use. So yet another line is going to be appended to this text file. This is how we write and read text files. So after closing, let's just demonstrate one simple example again. So I'm doing A, and if I'm closing the file, if I try to write after the close operation, so you can do the text file. So if I try to write it, you throw an error. So after closing the file, you cannot write. So we have to write all the text that we want to write before we close the file. Once it is closed, it's closed. We can't write anything to it. It will throw a section. So that's about how to write read from files. So I just want to show you the JSON syntax also. JSON is a serialization format. Let's say if I have a dictionary. So JSON is by default comes with the Python installation. JSON is a package which will be used in most of our STLs. So this is important. So if I have a structure, let's say my dictionary, let's say a table. So I can actually write this into a file. This data structure I can write into a file, but before writing this data structure, we need to serialize that into a specific format. So in all web programming, we use JSON extensively for writing and reading, for serialization of data representation or data structures in the code. So in order to write this to a file, I have to do with open, say a.json. This name can be anything. W as f dot write or JSON dot dump string DOPS or the dictionary. So what this does is it will convert this dictionary into a serialized representation called JSON representation. So once I write this, then I'll show you how this JSON representation works. That's it. We can just execute this file and see a.json. If I go to a.json, and this is how it writes. Although this looks like this same structure, but it is not actually a data structure environment. It's a serialized format. It's a string. So similarly, if I do open and read more and read this text, I'll just print that. I'll just comment out this portion. If I read this JSON file, this does read this as a string, not as a data structure or a dictionary. It's, and this is printed as a string. So if I do type of f.read, that's actually going to be a string, not a dictionary. If I do the type of my dictionary, it will show as dictionary. So my dictionary is actually a dictionary data type, and once I serialized it into JSON and read the same JSON, that is actually a string. So in order to convert this string into another data structure like my dictionary, so unpacked, data structure. So this f dot read, I'm going to store it in one variable, JSON data equals f dot read JSON dot low string of JSON data. If I do this, whatever is serialized into JSON format, that same data will get converted into a dictionary. So this unpacked data structure will be again a dictionary. If I do print that and the type of unpacked data structure, the type will become dictionary. So once I write it, if I read it, I have to make sure that it is loaded as a data structure from serialization. So this is what is called serialization, and this is what is called deserialization. So a program data structure representation, once it is, if I have to write it into a file, I have to serialize the data and then write it as a string into the file, JSON file in this case. So if I'm reading from the file and preparing a data structure in the memory, I have to deserialize that. So that is what we did with loads, deserialization, and serialization with dump. Dump S means dump string, and load S means load string. So let's do this. Now, if I had read it and unpacked it or deserialized it, that is becoming a dictionary. So that's about JSON. We can actually write custom encoders and decoders for objects. How do I write custom encoder and decoder for objects? Let's custom decoder everywhere. So let's say I have a class called animal. And we will information to it. That's important. Now I have a Python dictionary that says A as animal. Outward. B as yes. Just one should be object. So it works with JSON.dumps works with plain strings and plain data structure, data types that Python uses. So if I have custom data types like classes or objects, if I try to do JSON.dumps Python dictionary, so I need to import JSON here. If I try to execute this, object of type animal is not JSON serialized. So this object, Python doesn't know how to serialize this object. So in order to work around this and in order to create custom serializers, this is important when we are working with our own custom objects and JSON responses in the HTTP servers. So I need to include another class called JSON encoder. So I need to write another encoder for animals. How to encode animals with a JSON string is animal encoder. This extends JSON encoder. This is inheritance we discussed in the last class. I'll go over this one more time. Here, I need to override one simple function called default. I'm writing custom encoders. I have to override a function called default. JSON has encoded all the properties, attributes, methods will be inherited from JSON encoder here. So I'm just going to override default method. So this accepts first argument as self, and the second argument is the object itself. So I'm giving the name as O here for the object. So what I need to do here is return super dot. If if it is object of type of object is equal to animal. So we have to make sure that we are only encoding animal objects. So this O can be anything. If somebody has used some other class and created an object and passed that object, we should not serialize that with this encoder. So it's an array. So if we don't see that this is, let's just do pass, do nothing. If the type of object is animal, then we need to do serialize that, return something called animal the self name. So when I'm serializing this animal object, I need to return the name of the animal in the default. So serialize it. If it is not an animal object, we have to call super classes default is an object. And that's it. So this is how we write a default custom encoder. So now if I do the same thing with JSON terms, and this time I'm going to pass in the encoder function. What's the encoder I need to use? I can specify with an argument called class equals animal encoder. This will be able to serialize the animal objects. By convention, it has yes text value as an animal object. So I can try now execute no matter images of encoders. Oh, because we have to use a separate syntax for this from JSON import JSON encode. JSON encoder itself is not a module. It's a class within the JSON module. This is how we import a specific class with JSON and inside of that. So I'll go over what modules, how to create our own module. Okay. So let's run it. Has no attribute name. Actually, I should use O, not self. O dot name, object dot name, or data. That's done. Let's say I have a class called animal and I have a property or attribute called name in it, and I have a dictionary that has key as a and value as animal object. If I directly try to print serialize this dictionary because animal object is there, it doesn't know how to serialize the animal object. It can serialize basic data types like integer, float, or string, or any other basic data types in Python. So if I do this now, and this object of type animal is not JSON serializable, this kind of error is thrown by the Python. Now, in order to give the hint of how to serialize this animal object to Python or to the JSON library, we have to have an encoder called JSON encoder. JSON encoder is the default encoder that is used by JSON library when I'm doing the dumps function. So I have to extend this functionality to make sure that the serialization works with. And so serialization in the sense when I'm doing JSON by dumps, that means we are converting this Python object into a serialized format called JSON. That is what serialization is. So for this, for making sure that animal object is serializable, we have to create an encoder. So we have introduced to an animal encoder that inherits from JSON encoder. And one thing, only one method I need to override in animal encoder is the default method. And by default, it accepts the first argument as self and second argument as the object itself. So whichever object, if I'm serializing this entity, JSON library will pass in this object in place of O. So here, what I need to do is, if the object type is animal, then only I have to return O dot name, object's name. So this is the name, right? This object I'm referring. So this A object is nothing but an object of type animal. So if I'm doing O dot name, that means this animal's name is storing. This name is what will be returned. If it is not a type of animal, then I have to call the supers whatever default functionality that JSON encoder gives. If it is an integer, it will not get passed to this. But the thing is, we have to always handle the data type. If the data type is animal, then only I have to do this. Otherwise, just use the super classes default. Just use return after return. So in this particular scenario, I'm commenting out just, and I can give a hint to JSON dumps method on what classes to use for serialization. That is through CLS argument. If I see the documentation here, CLS equals, it should pass in JSON encoder. So JSON encoder, we have implemented animal encoder. Animal encoder. When this is called with this clue, if you don't know how to encode a specific item, just call this guy. That's what we are hinting to the JSON library. Now if I do execute this, and the result is this. When I'm calling the encode, it's giving the name. In this place, it's serializing A as hardware with the name of it. So this is about encoding JSON serialization, writing files, reading from files to everything. Let's now visit a concept called modules or packages in Python. So any package, any file can be considered as a package. Let's say I have a file called primes. So let's say now we'll go into the modules concept. Let's say I have a file called primes, and in this I have, let's say, one function is prime function that accepts a number and accepts on primes. This is all logic that we can use to find the prime, whether it is a prime number of on primes equals range into 0 and to power of 0.5. This I have already explained this logic to you when we were discussing about functions. If it is prime, if it is found in previous primes, so what we are trying to do here is, if I have to find out whether a number is prime number or not, we're just trying to get the list of prime numbers that were found from range 2 to the power of n to the power of half. So that is square root of the current number. That is a basic formula for finding prime numbers. So we have to check all the factors. So these are the factors. Let's say if a factor in primes, you have to see if this is number is divisible by the factor and odds. Otherwise, reduce. So this is just to demonstrate a functionality with modules. We don't have to have this kind of complex function also. So I have, let's say I will declare another function called list primes up to a number, maximum number. This in turn calls this function found primes as an empty. Let's say we initialize this one. So n in range will come on max is prime. If is prime, then I will found the primes. Found prime start of n. This we are actually collecting all the prime numbers into a list. Done from primes. Forget about the logic over here. Just remember there is two functions and one file called prime start. I will have one more file called use module. So modules, how do I use modules? Or like I have this in a separate file, and how do I use this code inside this file? That is through importing another file into this. Just like Java, we have import statements. Similarly, we have import type. So if I do import the primes, this imports entire primes.py into this file. So now I can actually call list primes and primes dot is prime of file. So maybe I can have, let's execute this now for now. Python module. Okay, this is printing. file is next. So I can also import in a specific function itself. I'm right now importing the entire primes file into this. I can also import only this function into this those modules. That is through from primes import list primes. List primes is the function name. So only this entity I can import later. So now I can actually call print list primes of maximum number, let's say 20. Okay, this also works. It listed all the primes from 20. So this is how we use another file in one file in another file. And what if I have to bunch, collect together a set of files into a separate package? So a package will have multiple files in it. So one file is fine. One file we can directly import it like this and use. I want to implement a package. I can create a folder for a package. And inside it, I have to create a special file called init underscore underscore init underscore underscore .py. This actually says to Python that this is a package. My package is a package. So I will have one file created here called factors. So this has a function. Let's define function here. Get factors of that. It gets a number and it finds out all the factors of that number. That actually is going to return a list of factors. Factor factor n range on n plus 1 if n divided by factor modulus yes n modulus factor is 0. So this means, so go through 1 till the number 1 to 10, let's say 10 is 10, till from 1 to 10, check if any number is dividing this n number exactly. If it is exactly dividing, then it actually is a factor. So in the same code, let's say I will write another file in this package called primes. .py. I'll implement a function called isPrime again inside this. If I give a number to it, from primes equals now. Similarly, return get factors. So the definition of a prime number is that the factors of that has to be a number has to be 1 and itself. So there should be only 2 factors, which is 1 is always a factor to any number, and that number itself, let's say taken 7 as an example. 7 is divisible by 1 exactly, and it's also divisible by 7 exactly, which means there are only 2 factors to 7, which is 1 and itself. So this get factors, we are checking if the length of get factors, number of factors that it has is only 2, whether it is, if it is only 2, that means 1 and itself is the factors, then it is a prime number. If not, it is not. This get factors I can import from this package, my package factors. Let's import that with that format from my package, import get from package, my package dot factors, import get factors. This imports from this my package, from this file, import this function. That is what this says. Let's try executing this. My package comes without doing. Not really without my package. Let's go inside my package. My package is not defined. I am going to remove this times outside of this package. Problem comes to that. Okay. Let's go back to this prime student line. What we are doing here, we are importing from my package factors this get factors function. So when we tried it within that file, it's actually trying to refer to my package, which is not found within this. If there was another package called my package here, that would have detected. So as this file was within this package, it wasn't able to recognize this my package. If I had accessed directly like factors, it would have recognized because within the same file, it doesn't have to refer to this package name. So if I'm writing another file outside of this package, I have to refer with the package name and the file name. Let's run this code in the primes.primes2.define. I'll just call this and this prime 5. Get factors needs an argument n. So that was a type mistake. So I have to pass n to the get factors. Get factors actually accepts one argument, which I forgot. So I'm passing n now. Let's run this code. And 5 is a random. So what if I remove this init.py? This is very important. I remove this init.py. It considers this just as another folder, not as a package. The Python doesn't consider my package as a package. Let's run this. It is in the time, so it's somehow it's in the cache itself. It's considering this thing as a package and make sure that we use init.py in any package. Otherwise, it will not recognize this. Let's create another package without this init. And those just use factors here. Let's remove this. This time we are going to see try without the underscore init. Now the name of the package is supposed to be numbers. Let's try numbers dot factors. Import get factors. Let's try executing this. And no module name numbers dot factors. Numbers is not a package because we don't have init inside the file. If I had init inside it, then now it would consider this. This actually means overriding the existing package. So this. Bringing this to my numbers. Package name is my numbers right now. I'm going to change this to my numbers. I don't have the init file in it. Let's try running this. But this is somehow it is working, but make sure that we have the init file created, without which the package mechanism doesn't work. Yeah, that's about packages, how to use them. So this is how we create a package. Every package will have an init file in it, which represents, makes sure that it is declared as a package, and Python considers that as a package only when it has init.py in it. Yeah, this is about modules, and this is the last of the lessons that you have to consider. And there is one small concept that we missed. So last time we have used multi-threading processes stuff even, and here I have used a special logic called if new equals make. So similar thing, let's try running that here. Find this print underscore name here. Let's see what this prints. Main. So it prints main. Whenever I'm executing a file directly, the name of that file is going to be main. If I do the same thing here inside the get factors function, it's doing this. We want to import factors from my numbers, import factor. When I import this, all of the code that is there in the factors file gets executed. Let's try to print that. When this gets executed, the name of it will also get executed. So the name here, let's just print in factors w in friends w Let's try running this. In factors.p1, the name is numbers.myFactors. This actually gives us the package name in which the file exists. So when we are executing primes2.p1, by default, it comes in the main package. Any starting level code that we run to the Python comes under main package. That is why the name is main. So when we used main.py in process UI, when we check the name to be main, this means that we are using this file as a main entry point to source code, main entry point into the Python execution logic. So that is what we are making sure. So this is executed as a main package. So only when this is imported, if it is imported, that will not become a main package. That won't come under main package. That's the difference between using a package and a plain Python file to execute code.